In the previous lecture, we talked about periodic functions, and also we talked about odd and even functions. We also talked about integration of odd functions and even functions. We said if f of x to be an even function, then its integration, then we say the integration of an even function from negative L to L dx is equal to 2 times the integration from 0 to L for the function. But for the integration of odd function, integration from negative L to L for f of x, where f of x to be an odd function, dx, it equals to 0. If you have an odd function, then its integration from negative L to L, that means from negative a number to the number in positive sign, its integration is 0. But for even function, if the function is even, it equals to 2 times the integration for the function from 0 to L. We talked about this before. Now we say if f of x to be an even function, if f of x to be an even function, then the multiplication of 2 even functions is an even function. The multiplication of 2 even function is an even function. But multiplication of an odd function with an even function is an odd function. Here, f is an even function, and sine is an odd function, but cosine is an even function. Okay, we say the integration of f of x times sine nx dx, this equals to 0. Why? Because the multiplication of these two functions is an odd function, and the integration of an odd function from negative L to L is 0. And here we say if f to be an even function, if you multiply it by cosine nx, cosine is an even function. Cosine x is an even function. Even times even is still even. That means here the multiplication of these two functions is an even function. So the integration of this even function from negative L to L is equal to 2 times the integration of the function from 0 to L. That means if we take the integration of f of x times cosine x, let's say from negative pi to pi dx, this equals to the integration for the function, which is f of x times cosine x from 0 to pi, but we multiply it by 2. These two are the same. We can take the half of the range, half of the range, and we multiply it by 2. Then if f of x to be an odd function, say if f of x to be an odd function, then the integration of f of x times sine x, odd function multiplying by odd function, is an even function. Odd times odd is an even function. Here the multiplication of these two functions is an even function. Our integration of an even function from negative L to L is equal to 2 times the integration for the function from 0 to L. But f of x times cosine nx, cosine is an even function, and f of x is an odd function. Their multiplication is an odd function. Its integration from negative L to L is 0. Okay, for example, if we take an example, the integration of x from negative 2 to 2 dx, here we don't need to find the integration, we just can say it's 0. Why? Because this f of x is an odd function. Its integration from negative L to L is 0. Okay, but the integration of, let's say, from negative 2 to 2 for x squared dx, here f of x is an even function. It equals to 2 times the integration from 0 to 2, we take only half of the range, for x squared dx. Okay, you can see that. Now you have Fourier series for periodic function f of x consisting of sine and cosine. In finding the Fourier series, we have sine and cosine functions in the integrations. We say the Fourier series for f of x, that is generally the Fourier series for a function f of x, if f of x is neither even nor odd. If f of x is neither even nor odd, we say f of x is the Fourier series expansion. It equals to a naught over 2 plus the summation from 1 to infinity for an times cosine n pi over lx plus bn times sine n pi x of l. Here we should we just need to find a naught, an and bn. This is the general form of the Fourier series for the function f of x. This is Fourier series for f of x. Here we just need to find a naught, an and bn. We can get each of these by using these formulas. For finding a naught, we say it's 1 over L. L is the upper bound of the interval. It's the upper bound of the interval. The integration from negative L to L for f of x dx. That's a naught. For an, we say it is 1 over L times the integration from negative L to L for f of x times cosine n pi ax of L. But for bn, we use sine. It is 1 over L integration from negative L to L for f of x times sine n pi x of L. These formulas are used for finding a naught, an and bn. After finding these, we return them to the formula. To the above formula, we get the Fourier series. Okay. Here we say if f of x is an even function. If f of x is an even function, let's return to here above. If f of x to be an even function, if it's an even function, bn is 0. Why? Because it's an even function and this is an odd function. Even times odd is odd. So the integration of an odd function from negative L to L is 0. This is in the case if f of x is an odd function. So here we just need to find a naught and a n. In this case, we just find a naught and a n because bn is 0. And if, and let's see what's the Fourier series formula. In this case, if f of x is an odd function, if f of x to be is an even function, we say it is a naught over 2 plus the summation an cosine n pi x of L. As you see, comparing to the above ones with the general form of the Fourier series, we have no bn. That means this term becomes 0 because bn is 0. So we get only this part of the formula. This in the case if f of x is an even function. But if here, this is how to find a naught and a n. And if the function is an odd function, if f of x is an odd function, here a naught and a n are both 0. A naught and a n are both 0. Let's set up here. A naught, yeah, this is an odd function, and this is also an odd function. We say if f of x be an odd function, then a naught is 0. Why? Because the integration of an odd function from negative L to L is 0. We said that before. And a n is also 0. Why? Because here we have an odd function, and cosine is an even function. Odd times even is odd. So this function is an odd function. This is odd function. And the integration of an odd function from negative L to L is 0. Both are 0. And we only have Bn. We only have Bn. So let's take some examples. Here we say if f of x is neither odd nor even, we use formula 1, which is the first one, the general form. This one. We use this. If the function is an even function, we use this one. And if the function is an odd function, we use this. Here we have an example. It says find the Fourier series for this function. The function is given, which is negative x. F of x is minus x. In this interval, this is the interval. That means minus L to L. It's from minus L to L. And L is 1, is it? L is 1. L is the upper bound for the interval. And it's given that f of x plus 2 equals f of x. Here we say if f of x plus t equals f of x, it means the period is t. So period t. The period is t for the function. It's given that f of x plus 2 equals f of x. Sorry. In this example, we say we have given that f of x plus 2 equals f of x. We say if f of x plus t equals f of x, it means the period is t. Here, t is comparing to this example, to this one. We can get that t is 2. It says determine t and L. T is the period for the function. So t is 2. What's L? L is the maximum value in the interval. The maximum value in the interval is 1. Since this interval is from -1 to 1. This is the interval. Okay. 1 is the maximum value in the interval. It's from minus L to L. L here is 1. So L is 1. Now we have T and L. It's answer for the first part. For the second part, it says draw the graph of f of x. We are going to draw the graph for the function in this interval. In this interval, we have given that its x is between -1 and 1. We draw the graph of f of x to be negative x from -1 to 1. You see f of x equals negative x. We are going to draw it from -1 to 1. Okay, this is a linear function. This is a linear function. We can give any two values to the function, then we join these values, you get the result. We get the graph. If let's find f of 1, it is -1, and f of -1 is 1. F of 1 is -1. And f of -1 is 1. We join these points. We join these 2 points to get the graph. This is the graph for this is graph of the function in the interval -1 to 1. This is graph of f of x, which is -x minus x. Now we check whether f of x is odd or even function or neither, and identify the corresponding formula. Here we are gonna check that the function is either odd or even or none of them. Let's see. We are gonna find f of minus x. If it equals to f of x, that means it's even. But if it equals to negative f of x, it means the function is odd. So First, let's write down the function itself. We have given this function f of x is minus x. We are going to find f of minus x. We replace each x by negative x. We replace each x by negative x. This equals to negative x. This equals to x. Okay, and this equals to negative f of x. If you multiply f of x by -1 and by negative x, we get x. That means f of negative x equals to negative f of x. So it means the function is odd. It's an odd function. This is an odd function. And now we calculate the Fourier series for the function. To calculate the Fourier series, we have an odd function. We said if the function is odd, then a0 and an are both 0. Since the function is odd, it means a0 and an are both 0. Let's return to the above notes. Here we say if f of x is an odd function, then a0 and an are both 0. And the Fourier series is this formula. In the formula, we have only bn. We are going to find bn. How? By using this formula. We are going to find this integration, which will be bn. We say bn is 2 over L times the integration from 0 to L, f of x sine n pi x of L dx. This is bn. Okay, so let's write down it here. We say a0, and since the function, we say since the function is an odd function, then thus a0 equals 0 and an equals 0. And the Fourier series formula is the Fourier series formula is the summation from 1 to infinity for bn times sine n pi x of L. And here we need to find bn. So bn equals 2 over L integration from 0 to L for f of x times sine n pi x over L dx. Here we replace L by its value. L is 1, we found before. Okay, in the first step we found L, which is 1. And we also replace f of x by the function. The function is negative x. We have given this function. The function is negative x. We replace by negative x. And we replace L by 1. And then we find the integration. Here, bn equals 2 over 1, which is 2. Because L is 1, so it's 2. Integration from 0 to L. L is 1. For f of x, which is negative x, times sine n pi x over L. L is 1. And we just can write down like this. Okay? Because the denominator is 1, yeah, L is 1. So you can say it is n pi x. Okay? dx. Now we find this integration. This integration can be found by integration by parts or UDV. Okay, I'm going to use the short methods. Here we have derivative and integration. كم عندنا derivative? We have these two functions. كام يعني A بس صفر derivative أو عندنا بدري. Okay, we have a negative x. Let's put this negative sign to out of the integration. Okay, this negative sign I'm gonna put it here. Okay, so d is x, and the other function is sine n pi x. We take the derivatives for x, so we get 0. The first derivative is 1, and the second derivative is 0. By taking two derivatives, we get 0. And so we must take two integrations for the other function also. You'll not get any results. You'll not get any results. It's wrong. No. It's a wrong way, yeah. For example, sine times, yeah, sine times cosine. At that case, you just need to take two integrations, two derivatives and two integrations, and then do the process, divide by 2. At the end, divide all the process by 2. Just a minute, I'm going to tell you and you'll solve an example. Yes. Okay, we'll do it. Just one. Here, for the first integration for sine n pi x is 1 over n pi, negative 1 over n pi, cosine n pi x. Then we take another integration for cosine is sine, and is negative 1 over n pi squared sine n pi x. Now we multiply these two, then we multiply these two, and we add a negative sign for it. Okay, we add a negative sign for it as well. Yeah, in multiplying the second step, we give a negative sign to it, and the result for this integration is negative 2. Then we have x times negative 1 over n pi cosine n pi x. It's minus x over n pi times cosine n pi x. Then plus. Here we have a negative sign times negative sign, it becomes positive. Then 1 times 1 over n pi squared. It's 1 over n pi squared. Sine n pi. It's from 0 to 1. That's from 0 to 1. We now replace x by 1 first, then minus, we replace x by 0. N pi x, yeah, here we have an x also. Thanks. Now we replace x by 1 first, and this equals to negative 2. If you replace x by 1, this becomes negative 1 over n pi cosine n pi plus 1 over n pi squared sine n pi. Then minus, we replace x by 0. This becomes 0 because it's multiplied by 0. It's multiplied by x. If you replace x by 0, we get 0. This term becomes 0. And this term, if you replace x by 0, we get sine 0. And sine 0 is 0. That's 0. We get 0. For both terms, if you replace x by 0, the first term becomes 0 times cosine 0. Okay, which is 0. And the second term becomes 1 over n pi squared times sine 0. Sine 0 is 0. That's why you get 0. And this equals to, look, sine n pi, this is x-axis and that's y-axis. N pi is always on the horizontal axis. N pi, 0 pi is here, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And in the clockwise, negative pi, negative 2 pi, negative 3 pi, negative 4, like this. Okay, so n pi is always on the horizontal axis. At the horizontal axis, sine is 0. sine is 0 at the horizontal axis. Sine is always 0 at the horizontal axis. So here we say sine in pi is 0. Why? Because in pi is always on the horizontal axis, and sine of any angle on the horizontal axis is 0. This is 0. Okay, and this one, for cosine, this is x, that's y. Here for cosine on this part of the x-axis is 1. Let's make the circle. This is a circle. This point is 1 and 0. This point is 0 and 1. This point is -1 and 0. This point is 0 and -1. We say the first element represents cosine of that angle. Yeah, this is cosine, and this is sine. That means any angle on this side of x-axis, its sine is 0 and its cosine is 1. Its cosine is 1. Okay, and here for the angles on this part of x-axis, its cosine is -1 and sine is 0. That's why you say in pi it always has 0 sine, but it is 1 if it's on the side, and it's -1 for the side. That's for cosine. For cosine, the cosine of the angle on the horizontal axis, if it's in the right hand side of the x-axis, we say that the cosine of that angle is 1, and for the left hand side we say it's negative. هرقوشي كوتست أم هي الله هرقوشي كوتست أم هي الله علين كوساينكي صفر يكا ساينكي صفر كم قوشانك ونسرية صفر plus minus 2 pi plus minus 4 pi and so on. That means all the even angles, in pi, where n is an even number. Okay, if n is even, we say the cosine for the angle is 1 and the sine is 0. If it's on this side, it's in the other side, it's here. We say this pi plus minus pi plus minus 3 pi plus minus 5 pi and so on. Here we have the odd angles. So the cosine for pi and negative pi is -1, and the sine for it is 0, and for 3 pi, 5 pi and so on. For the odd angles, the cosine of n pi, for n pi, the cosine of n pi, if n is odd, is -1, but if n is even, it is 1. Okay, now let's return to the Fourier series for Bn that you are gonna find it. We say this part is 0 because it's sine n pi. It's on the horizontal axis. Sine is always sine of the angles on the horizontal axis is 0. But cosine, if it's in the right hand side of x-axis, it is 1, and if it's in the left hand side, it's -1. That means we say it is -2 times -1 over n pi times cosine n pi. We get this. Now, what we do, we say cosine, it's either -1 or 1. When it's -1, if n is odd, and so on if n is even. Okay, that means it equals to -2 times -1 over n pi times -1 to the power n. It's -1 to the power n. If n is odd, we get -1. If n is even, we get 1. That's for cosine. So we convert cosine n pi to -1 to the power n. Okay. And this equals to 2 over n pi times -1 to the power n. This is Bn. This is Bn. Okay. Now, we are going to put Bn into the formula. Yeah, this is the formula. If the function is odd, we use this formula to write down the Fourier series. We say f of x equals the summation n from 1 to infinity for Bn times sine n pi x over L. We just replace L and Bn by their values. L is 1 and Bn is 2 over n pi times -1 to the power n. We say f of x equals the sum n equals 1 to infinity. For Bn, Bn is 2 over n pi, 2 over n pi times -1 to the power n times sine n pi over L, n pi x over L. L is 1, which is sine n pi x. If we divide this by 1, it's still n pi x. Now, here in the series, we have 2 over pi with constant. We can take it out of the series. We can take it out of the series. We take 2 over pi to the outside of the series. So f of x equals 2 over pi, the series, and from 1 to infinity for -1 to the power n dividing by n times sine n pi x. This is the Fourier series. Here, in finding the Fourier series for a function, we just need to find a0, an, bn. Here in this example, a0 and an are both 0. So you just need to find bn. We found bn and we return to the formula. And we get the Fourier series. This is the Fourier series for the function. Sorry? Yes, it's the final result. It's the same as it's given there. Okay, let's take a break. Here we have another example. It says find the Fourier series for this function. F of x is -x, where x is from -pi to 0. And f of x equals x, where x is from 0 to pi. This is a piecewise function. We can say f of x equals the absolute value of x. This is the definition of absolute value. Here, x is from -pi to pi. That means in the interval -pi to pi. This is our interval. And here L is pi. L is the maximum value in the interval, which is pi. Here, L, it says determine T and L. We say L is pi. How about T? T is the period. It's given here. T is 2 pi. Capital T is 2 pi, which is the periods. Now, we should draw the graph of the function. Let's draw the graph for this function. We say this is x and this is y. From minus pi to pi. From minus pi to pi. We have f of x, which is an absolute value of x. So absolute value of x is a V shape. It's a V shape like this. Here, this is pi. It goes from here to there. Sorry. Yeah. This is the graph for the function in the given interval. You must draw the graph for the function in the given interval. Okay. It's from negative pi to pi. So it's the graph for the function. Now we check whether the function is even or odd. So f of x is an absolute value of x. We find f of minus x. F of minus x. If it equals to f of x, it means it's even. If it equals to minus f of x, it's odd function. If none of them, we say it's neither odd nor even. Okay, let's check for this function. We find f of minus x. We replace x by negative x. We get minus x in an absolute value. It equals to absolute value of x. But absolute value of x is the function f of x itself. This equals to f of x. Which of the above cases is that? It's the first case, was even. Okay? Because absolute value makes every negative values to absolute value makes every negative value to positive. Here we have minus x becomes x. This equals to, so you say f of x is an even function. It's an even function. Now we are asked to find or to calculate the Fourier series. We should calculate the Fourier series for f of x. Here, since the function is even, we say f is even. That means Bn is 0. Bn is 0. What else should we find? We should find a naught and a n. We should find a naught and a n. And the Fourier series formula is this one. Since Bn is 0, we have no Bn in the formula. We have only a naught and a n. We find a naught and a n, and then we return them to this formula, which will be the Fourier series. Let's find a naught and a n. We say a naught equals 2 over L. You should know these formulas, okay? We talked about these formulas above. Here we find a naught. A naught is 2 over L, the integration from 0 to L for x dx. The function is x. Okay? Our function is x. It's the integration from negative L to L for absolute value of x dx. But if you take only the positive part, as you see here, it's given that from 0 to pi, from 0 to L is x. We take only x. We don't take negative x. This is the formula for finding a naught. And this equals to, we replace L by its value. L is given. L is given, which is pi. L is given, which is pi. And we found it. L is pi. We say it equals to 2 over pi. integration from 0 to pi for x dx is equals to the integration of x is x squared over 2. It is x squared over 2. It's equals to 2 over pi x squared over 2 from 0 to pi. We replace by pi first, then by 0. If we replace by pi, we get pi squared over 2. We get 2 over pi multiplying by pi squared over 2 minus 0. If we replace x by 0, we get 0. And then these are cancel out, and this square with this one are cancelled, and we get only pi. That means I naught equals pi. This is I naught. This is I naught. Now we find an. We find an. An is 2 of L, the integration from 0 to L, f of x cosine n pi x of L dx. Here we replace L by its value. L is pi. L is pi. We say it equals to 2 over pi. Integration from 0 to pi. For f of x is x. For the positive part of the interval. For the positive part of the interval, we have only x. We write down from 0 to pi. From 0 to pi. From 0 to pi, we have x. We have no need for x. We just write down x. F of x is x cosine n pi x over L. N pi x over L. L is pi. These two are cancelled out. Okay? And this equals to 2 over pi. Integration from 0 to pi. For x cosine nx. X cosine nx dx. Because these two pi I cancel out, so you get only cosine nx. We now find this integration. We can use integration by parts or UDV. Here I'm gonna use the short method for finding this integration. Its derivative is x and integration is cosine. Cosine and x. Now we check a derivative for x till we get 0. First derivative becomes 1. The second derivative becomes 0. So you just take 2 derivatives. Since we took 2 derivatives for x, so we must take 2 integrations for the other part. We must take 2 integration for cosine nx. The integration of cosine is sine. And we must have the derivative of the angle, which is n, and we get 1 over n sine nx. Then we take another integration. Integration of sine is negative cosine. And the derivative of the angle is n. We multiply it by n and divide it by n. We get minus 1 over n squared cosine nx. Now we multiply these two, the minus, we multiply these two. So the integration, this equals to 2 over pi times x times 1 over n sine nx plus, here we have a negative sign times negative sign becomes positive sign plus 1 over n squared cosine nx. It's from 0 to pi. We now replace x by pi first, then by 0. If we replace by pi, we get 2 over pi. Here we get pi over n. X times 1 over n is x over n. Okay? It's pi over n sine n pi, which is sine 0, because we said on the horizontal one, for the horizontal angles, sine n pi is 0. Sine is 0. N pi is the horizontal ones, so it's 0. Plus 1 over n squared cosine n pi. This is for pi. Then we replace pi 0. We replace pi 0. For this one, we get 0 times sine 0. We get 0. 0 plus 1 over n squared cosine 0. That's it. When we replace by 0, the first term becomes 0, and the second term becomes cosine 0. And cosine 0 is 1. This equals to sine n pi is 0. Is it? Sine n pi is 0. It's 2 over pi. This term is 0. So you just have 1 over n squared cosine n pi minus. Here we get only 1 over n squared. We get only 1 over n squared. Why? Because we have cosine 0. Cosine 0 is 1. And you get only 1 over n squared. Now we have cosine n pi. Cosine n pi, it depends on n. If it's even, it is negative 1. And if it's even, it is 1. But if n is odd, it is negative 1. So you can write down as minus 1 to the power n. It equals to 2 over pi times 1 over n squared negative 1 to the power n minus 1 over n squared. And we can write down as, we take 1 over n squared as the common, we get 2 over pi. So pi n squared. It is 2 over pi n squared. We take 1 over n squared as the common. And what's left? Here we get minus 1 to the power n minus 1. If n is even, we get 0. If n is odd, you get 4 over n, 4 over pi n squared. Is it? It's minus 4. If this is even, this becomes 1. 1 minus 1 is 0. That means if n is even, n is 0. But if n is odd, this becomes negative 1. Negative 1 minus 1 is minus 2. We get minus 4 over n pi squared. An to be like that. We don't need to do that. Here, what we do, we just plug this into the formula. This is Bn, this An. So An is that. We found A naught, which is pi, and An is this, 2 over n pi squared times negative 1 to the power n, negative 1, minus 1. We plug these into this formula. Okay, A naught and An, and also L. L is pi. We replace L by pi. A naught by pi, okay, and An by 2 over n pi n squared times minus 1 to the power n, negative minus 1. Say put I naught and An in f of x equals A naught over 2 plus the sum n from 1 to infinity. And from 1 to infinity for An cosine n pi x over L. So f of x equals, I know this pi, we found it before. I know this pi. It's pi over 2 plus the sum n from 1 to infinity For an is 2 over n, 2 over pi n squared times -1 to the power n minus 1. All times cosine n pi x over L, but L is pi. We replace by pi. These two are cancelled, and we get only nx. This is the Fourier series for the given function. This is the Fourier series for the given function. Okay. Here, we just look at the function. If it's even, we just find a0 and an. If it's odd, we just find bn and return to the formula. That's all. Okay. We now have this example. It's enough for today. Time's up.